Hi, thanks for coming to Dawit Academy, where you can access amazing resources in math and science that will help improve your performance in high school, college, and university. In this video, I'll be going over how to prove the trigonometric identity, sine to the power of 6x plus cosine to the power of 6x equals 1 minus 3 sine squared x plus 3 sine to the power of 4x. Now, just before I get into the solution to the problem, I would like to please ask if you like my videos and like to help grow this channel, that we can grow together, please subscribe, click on the subscribe button and click the bell notification icon. I'll be uploading more and more videos on YouTube pertaining to introductory math, algebra, pre-calculus, and other math courses, including science courses as well, chemistry, biology, and physics. So please subscribe now and be the ones early on that will receive these videos that will help you and give you not just a refresher but also introductory concrete solutions to problems and how to approach the problems from an analytical perspective, from a mathematical way of solving things and looking at solutions. So in this video, I'm going to be going over the solution to this trig identity. And what we do in trig identities is that we first need to choose a side. So we first identify what are the equations that we're trying to equate, and then we decide where we want to start the trig solution. So in this case, we have sine to the power of 6x plus cosine to the power of 6x on the left side, and on the right side you have 1 minus 3 sine squared x plus 3 sine to the power of 4x. Now, as a little tip, it's usually easier to solve going from a higher degree and simplifying the terms into a lower degree using trig functions and trig identities and rules that we cover, than going from a lower degree to a higher degree. So you'll see that different pattern when you solve many other problems or different types of trig identity problems. But in this case, what we first start off with is we work our way by using the left side. And in the left side we have sine to the power of 6x plus cosine to the power of 6x. So what I notice from a first bat is, can we rearrange this in terms of a perfect square or a sum of cubes? As you can see, we can rewrite this as a sum of cubes. So we write it as sine squared x to the power of 3 plus cosine squared x to the power of 3. And we're rewriting it as a sum of cubes. Now, the sum of cubes, if you remember the formula, it's a cubed plus b cubed equals a plus b times a squared plus a squared minus ab plus b squared. So we have sine squared x cubed plus cosine squared x cubed. So what I'm going to do here is apply the formula. The sine squared x is replacing a, and cosine squared x is acting as the b. So a sine squared x plus cosine squared x is a plus b. Sine to the power of 4x is a squared minus sine squared x cosine squared x is ab plus cosine to the power of 4x, and that's your b squared. So in the next step, we're going to use the Pythagorean identity. And as you know, the Pythagorean identity is sine squared x plus cosine squared x equals 1. So we're going to rewrite that into the formula. So just right here, definition of a sum of cubes. And we're going to replace sine squared x plus cosine squared x with 1. In the meantime, we're going to leave sine to the power of 4x. Now, I don't change sine to the power of 4x because if you notice in the right side of the solution, we have 3 sine to the power of 4x. So in some case, we're going to have to add terms to find 3 sine to the power of 4x. So I'll leave that there. But in the second term of the second factor, I convert a cosine squared x using the Pythagorean identity. I convert that to 1 minus sine squared x. And the reason is on the right side, we don't have any terms that have cosine squared x. With the same idea, we convert cosine to the power of 4x to cosine squared to the power of 2. from converting cosine squared to the power of 2, we change cosine squared using the Pythagorean identity to 1 minus sine squared x, close parentheses, and that's all squared. So now every term here is either well, all the terms are going to be with respect to sine x, like as a function of sine. There is no cosine, which is what we want to see on the right side. So now I expand and simplify. Sine to the power of 4x minus sine squared x plus sine to the power of 4x. So what I did here is I distributed the negative sine squared x into the parentheses. So I got negative sine squared x plus sine to the power of 4x plus 1. So now what I'm doing here is 1 minus sine squared x is a perfect square binomial. 1 minus sine squared x to the power of 2 is a perfect square binomial. So I'll expand that using the perfect square binomial formula. And that is basically, if you have a minus b in parentheses squared, it's a squared minus 2ab plus b squared. So in this case, the 1 is acting as the a, and the sine squared x is acting as the b. So you rewrite that as 1 squared minus 2 sine squared x plus sine to the power of 4x. And then again, I'm going to expand and simplify the expression. So again, we have sine to the power of 4x, and we're going to add sine to the power of 4x plus sine to the power of 4x. That gives you 2 sine to the power of 4x minus sine squared x plus 1. Minus 2 sine squared x. So what I'm going to do here is I'm going to open up the parentheses, collect like terms, plus sine to the power of 4x plus 1. So I'm getting very close to my right-sided, the term on the right side is that's what we want. We want to prove that the left side equals the right side, so we collect again like terms, 2 sine to the power of 4x plus sine to the power of 4x, and then we're also going to collect negative sine squared x with negative 2 sine squared x. And then what's left in is the plus 1. So 1 plus 3 sine to the power of 4x minus 3 sine squared x. So we've achieved the right side. I'm just going to rearrange the equation on the right, or the equation that we solved for, just so that it's in the proper format compared to what the question is asking us. It really doesn't matter at this point. The equation is, the equivalency is there. It's just that for formality, we're going to rearrange. So we have 1 minus 3 sine squared x plus 3 sine 3 sine to the power of 4x. And now we have the solution. The left side equals the right side. Again, problems like these do take a little bit more time. It's not something that you can just get off the bat. The first step is the crucial step. If you can identify the sum of cubes and see how, when you apply the sum of cubes, the format, how it's approaching something very similar to what you see on the right side, or at least in terms of context, that you want to generate 3 terms with degrees of 2 and 4, then that'll give you like a good hunch that you're on the right track. So thanks for watching this video. Please like, share, subscribe to my channel, and I hope to see any comments in the comment box below. As well, I'll be uploading more videos in the near future. Okay, so as again, we solved the trigonometric identity, and left side equals right side. Take care. Bye-bye.